I do want to thank Chandal for asking me to be part of the Space Weather Conference. So just to give you a little bit of a background about me, I have been a broadcast meteorologist for 16 years, studying and talking mainly about meteorology. So space weather is something that has been more new to my wheelhouse. So the Gannon storm on May 2024, I was working for space.com, if you're familiar. And my editor came to me and said, hey, we've got an assignment for you. We want to talk about this sunspot. It's a beast, it's large. We haven't seen anything like this before. So we want you as meteorologists to write about it. And I'll be honest, I went to school. I have a Bachelor of Science in Meteorology, but I never took any space weather classes. So all of a sudden I was forced with the task of how am I going to communicate this to the public and how am I going to have it make sense? Because we've had some amazing speakers today and everything that they've been talking about, everything all of the scientists and the researchers behind the scenes are talking about, we somehow need to get this to the public so they know what's going on, but they have it in an easy to understand manner. And so that's mainly been my job, as how I can write about this in a way that a 10-year-old girl can read about it and hear about it to somebody who's 40, 50, 30, whatever, and they want to know what's going on when we're talking about impacts from solar weather. Because when we think about it, we don't talk a lot about space weather on the news. We'll talk about the current terrestrial weather that's happening. And, you know, a big thing I've been learning in my career over especially the last 5 to 10 years is that space weather is huge. And it's something that really needs to be talked about, not just by journalists online, but also our broadcast meteorologists. And I'm a past chair of the Station Scientist Committee, and our job is to work with meteorologists at TV stations all across the country, both at the local level and the national level, to take everything that you are talking about, all the science, all the technical data, and presenting it to the public in a way where they can understand what's happening, but also they can learn a little bit about the science behind it as well. And so with this event, I had an assignment that I wasn't as familiar with. So immediately the task was, okay, how am I going to learn everything I can for something that I didn't know at the time was going to be a historic event? So using my communication skills that I've had from being a broadcaster, I had to think of the best ways that I could tell the space weather story. So of course, the first thing was I had to start my research. Yes, I'm a meteorologist. I know how the weather works here on Earth, but what about the weather in space? So immediately I started reaching out to my friends at NOAA, and I asked the scientists at the Space Weather Prediction Center, let's talk about this. Can you explain to me different things that I can break down and make it easy to understand to people at home? Because all of a sudden you're on social media, and as we know with social media, there's a lot of things out there. But how much of that is factual? How much of that is actually coming from people who know what they're talking about? Or is it somebody that read a chart or read that something's going to happen and all of a sudden we're looking at a space weather event? Because I'll be honest, at first I didn't know what a CME was. And most people that are sitting at home and are reading the newspaper or are listening to the radio or online, when they hear about, oh, this big CME happened, there's big sunspots happening, they have no idea what's going on. And so it's our responsibility as broadcasters that are scientists to find ways to communicate this to the public and tell a good story. So I immediately started to interview experts for my stories. I was putting out stories on space.com, which I'm going to show you in a bit, but I ended up having to do 10 stories within just over a week, which may not seem like a lot, but if you think about it, that's 1 to 2 stories a day that I'm doing on an event that the public is seeing as something that's historic. And a lot of people don't know what's going on and what's unfolding. So I was taking these interview experts. I was talking to people both with the government and also with private sector and talking a little bit about what they knew to help me best write this. And then of course you have to do social media posts. So you're putting stuff out there that you know is going to get the reach, but also making sure that it's accurate and everything that you're presenting is credible. So the next couple slides I'm going to show you are the 10 different articles that I did, starting on the first article that was on May 9th. We talked about the solar bursts and how all of a sudden now we had a geomagnetic storm watch. And for a lot of people at home, this was making the news. This was on social media, and they're like, wait a second, is this like a hurricane storm watch? Is this a severe thunderstorm storm watch kind of situation? So my first article, I was breaking down what a geomagnetic storm watch meant, how it was rare. This isn't something that we normally saw. And this was the first time a lot of these stories were starting to be communicated to the public, whether it was on social media, it was in online publications, or it was local meteorologists at their TV stations or at the national level that were talking about this. My second focus the next day was the sunspot. All of a sudden, it's 15 times the diameter of the Earth. So yes, in scientific terms, we have the numbers out there, but it's my job as a communicator to say, how can I put this into perspective for people to know how big this thing is? You can look at that little picture and think, oh, it looks like a scab on my knee, because I know I've definitely taken tumbles in my heels and it's looking like that. But 15 times the diameter of the Earth, that's how big the sunspot is. So I started to focus on the sunspot, what that was, what was going on. Then all of a sudden, on the 11th, we had the biggest solar flare yet from that sunspot. So all of a sudden, I was taking everything I talked about in my first two articles, while at the same time, I was learning things myself as a scientist and starting to put two and two together that, okay, this is forecasting. I'm a forecaster. I'm forecasting weather, though, on Earth. Now I'm going to be talking about forecasting weather that's going to be in space. So all of a sudden from there, we're talking about coming into a weekend when the big aurora happened. And I'm sure everybody can remember their story here. And by the way, the pictures on the backgrounds of the slides, which actually I think they got knocked out, which is a bummer because most of the pictures that I have in my presentation are from the aurora that I was able to see in Cleveland, Ohio. And I can tell you one thing, you don't think about seeing auroras in Cleveland, Ohio, but when that event happened, I was actually with my mom for Mother's Day, so it was a very special event. But all of a sudden, I was on social media, and I was watching in awe of how many people started to post. And then next thing you know, it was like catching fire. People were posting, and then people were seeing that it was happening, and they were running outside. And next thing you know, within a 5-minute range, social media was blowing up from different parts of the country. Oh my gosh, here are the auroras from Maine. Here are the auroras from Florida. Oh my gosh, I'm in Phoenix. There's an aurora here. And I also saw this as a turning point for storytelling with space weather because I realized everybody's like, this is cool. 1, is this going to happen again? 2, what am I seeing? And 3, are we going to start talking about this more? So great opportunity. My storm story on the 12th was all about, okay, we just saw this huge aurora show. So now what are we going to do to be able to talk about this again and keep that conversation going? Because like with anything big, with any breaking news story, this was a breaking news story for space weather. And as a meteorologist and a broadcaster, even though I wasn't on air at the time, I had an outlet such as space.com to write about this, but also to communicate with my fellow broadcasters that I knew across the country of, let's come together and let's talk about this storm. So then I started to do more articles. Next one was, oh my gosh, there was the 8.7 solar flare. So I switched my story there to now explain, okay, here's what we just saw. So let's go back and talk about another solar flare, because then the question with that one was, are we going to have a CME? Are we going to end up having the similar situation? So after doing a series of stories within those 3 days, I realized a lot of my colleagues in the broadcasting industry were talking about this. It's forecasting, just like we're forecasting as meteorologists. So my next article, and again, I cannot thank NOAA's Space Weather Prediction Center for the experts that I talked to help me tell these stories. Because yes, I am an expert in my background as a meteorologist, but space weather is a different animal, and I was still learning a lot of things. So the next thing, I sat down with these meteorologists from the Space Weather Prediction Center and explained how forecasting space weather is very similar to terrestrial weather here on Earth. Then we get to the end of the 15th. The sunspot's rotating out. Okay, all of a sudden now our story is changing. What's next? So I started to look into what I've already talked about, and again, communicating but building off the articles that I already read. So then we talked about a new sunspot region that was coming in. What were you going to expect next? And then the last article that I did with this series, which was actually really cool to talk about, when Tom and I were talking about this, is how that massive sunspot that brought the auroras to us here on Earth now is targeting Mars, a planet that has completely different layouts, completely different fields than us. So now I was taking the focus off Earth and saying, okay, this is actually really cool. And from everything we've learned, let's go to the next stop and talk about how this is going to impact the red planet, which was absolutely incredible. But like anything in life, there are challenges when it comes to communicating. And that's why it's so important to work with experts both on and off camera, because there was continuous misinformation, not just from credible sources, but non-credible sources. And I say that because unfortunately, a lot of people, and especially some broadcasters, got excited. This was something to talk about and to put on social media, but they didn't have the facts. They didn't know the experts to talk to because this was something that was new. But unfortunately, as we do see in the media, some people want to put stuff out there first. They want to get out there, they want to get out the information, but they don't know who to turn to get the facts. And so that was a challenge with this event, was it was something brand new, but I don't think enough people, especially in public figure locations, were finding the information to get that out there that was credible. And then you had the people that thought they were the experts that were sharing information that wasn't true. There was also limited resources at the time. I mean, yes, there was great information that's already at established locations. I mean, Johns Hopkins, NOAA, but a lot of broadcasters and journalists for digital did not know where to go to get this information. So that was a challenge. Now we know there's different people we can call, so we've been building a list, but that was something at the time of the Gannon storm that was an issue, as well as the lack of experience and knowledge on the subject. Like I said, I didn't know much about it. I kind of had to learn as I go. So here's what I think we need to do as a science community, and I'm hoping for future events that we can take the lessons we've learned, and all of the scientists out there can work with the members of the media, whether it's broadcast, whether it's print, whether it's digital, and make sure every broadcast meteorologist and journalist has resources and outlets, especially those within the American Meteorological Society. You are all talented and incredible brains behind the scenes, so let's work together and get that information out to our journalists and to our meteorologists so we can start to educate the public, so when the next event comes, just like when a tornado warning is issued, people will know what a geomagnetic storm watch and warning is. And by also doing this, we can do more public awareness campaigns. National Weather Service does great campaigns for being weather ready. There's a lot of great things out there. So now let's move that forward. Let's start to let people know that there's space weather that's going on that's going to impact us here at Earth, because as we know, this is still a very active sun cycle and we are not done yet. Yes, maybe it's going to take another 20 years, but what if not? What if we have in the next year another Gannon storm? And so by increasing the awareness, getting things out there, we can help with the collaboration between the on-air station scientists and the field experts, because broadcasters, whether it's TV, whether it's print or digital, we are here to work with you and take all the incredible work you are doing behind the scenes to make sure the public can easily understand what is happening. So let's keep the conversation going. I know we have time for a few questions, but on behalf of all the broadcasters, especially in the AMS community, I'm glad that I did all the work I did, because now I'm hoping moving forward we can come together and we can make a difference to communicate space weather to the public.
Thank you very much, Meredith. I'd like to encourage all speakers to log into Zoom. There are some questions from previous talks on Zoom that we didn't have a chance to get to, so if the previous speakers could log in and answer the questions in the comments, that would be great. Time for a couple questions here. We have one in the room and one online we'll take.
Mike Cook, the MITRE Corporation. Meredith, I really enjoyed your talk. I think there's a lot of opportunity for meteorologists, especially broadcast meteorologists throughout the country, to learn about the localized space weather impacts. So obviously those in the northern tier states, the aurora is the easy thing to talk about. Your local viewers have the opportunity to see it. But as we've learned through the Gannon storm and other space weather events, Midwest meteorologists, right, there's impacts to precision farming, GPS, agriculture, and then other things like the coupling of space weather and terrestrial weather. So for those in the South, maybe Florida, the Gulf, when you guys are responding to a natural disaster like a hurricane or flooding, there's impacts as well to the emergency management community via solar flares and HF radio blackouts. So I know a lot of us in this room view you broadcast meteorologists. You are on the forefront of educating the public. So there are a lot of folks in this room that would definitely love to keep the conversation going and to be a resource for you guys in real time. I know you guys have very short deadlines sometimes in the newsroom. Your station manager hears about something, they want it on, the 5 o'clock show.
Right.
I think a lot of us are very open to this. This was a great talk. So yeah, I'll definitely follow up with you after this. Appreciate what you're doing.
Thank you. And I do want to say, for this, I specifically focused on the auroras. A couple of my articles did go into the agricultural, the power grid aspect, but there is a lot of work to be done. And now, after what we've seen, like I said, I'm still learning, but I'm excited to go back to my bosses at space.com and say, let's talk about agriculture. Let's talk about the power grids. And for local meteorologists, find those local stories instead of just talking about the overall picture.
Thank you. Meredith, could you read the online questions? Or, I'm sorry, not Meredith, Mia. Could you read the online questions?
Of course. So one of the questions was, do you use feedback or comments on initial posts to inform what points to emphasize in future articles? What do you think is the biggest misconception the public has about space weather?
That's a very great question. And yes, I mean, personally, I love feedback because I know this is something that's not a perfect science. There's still a lot of things to learn. And one of my articles was about how the forecasters still struggled with this storm and how they were still learning while they were getting the feedback. And there were mistakes that were made, obviously, because we're still learning about a lot of things. So yes, I always encourage feedback, of course, if it's helpful, not hurtful. So, for the public, let us know. And if something doesn't make sense, talk to us. Or if I said something that's wrong, I'm the first person to say, let me know. I would rather come out and say I made a mistake and correct it than be putting false information out there. And for the second part of the question, I think the misconceptions is people think about space and they think these, like big explosions and crazy stuff. And the explosions are happening, but the impacts can be minimal, like seeing an aurora and getting excited, or it could be our astronauts someday are going to be out there and impacted by this, or planes at certain high levels. If it's too much radiation, there's issues. But also, when we're talking about it, it's not like the plane's going to disintegrate like in the movies. So I think it's like taking those misconceptions and doing stories like that.